Have you ever wondered how we predict the weather? It's not magic, I promise. It all starts with something called a weather model. Think of it like a giant, super smart computer program. This program takes in all the information we know about the atmosphere right now. Temperature, the wind, the air pressure, the moisture. It's a snapshot of our planet's weather at this very moment. These programs are incredibly complex, run on supercomputers. They are the backbone of every weather forecast you see. These models aren't just looking at the weather on the ground. They pull in surface observations and upper atmosphere data. They divide the globe into a massive grid, like a giant checkerboard. Each little box gets filled with data. The models use complicated math equations grounded in the laws of physics to predict what happens next in every box. It's like a planet-sized puzzle. Every piece affects the others. In the world of weather forecasting, we have two main heavyweights. These are the models we watch most closely, especially when a big winter storm is on the horizon. First, we have the ecmwf, which stands for the European Center for Medium-Range Weather Forecasts. We often just call it the Euro model. This model is a collaboration of many European countries and is based in Reading, England. The Euro model has a reputation for being the gold standard in medium-range forecasting, 3 to 10 days out. It's known for its incredible detail and accuracy. On the other side of the Atlantic, we have the GFS. This stands for the Global Forecast System, the American model, run by the National Weather Service. The GFS provides forecasts for the entire globe, and its data is completely free and available to everyone. This is a huge deal. Researchers and hobbyists worldwide can use it. The rivalry between the ecmwf and the GFS is friendly but intense. For years, the Euro was consistently seen as more accurate, especially for major storms. That spurred investment to improve the GFS, new dynamic cores and upgrades. The goal was to close the accuracy gap, and the race is tighter than ever. When a winter storm is brewing, meteorologists are glued to their screens, watching every run. We compare them, analyze differences, and try to pick the best forecast. So what makes the Euro and GFS models different? A lot of it comes down to the nitty-gritty details of how they are built. One of the biggest differences is something called resolution. It's like the pixel count on your TV. Higher resolution means more detail. In a weather model, higher resolution means the grid boxes are smaller. The Euro has historically had higher resolution than the GFS, letting it see small-scale features more clearly. Another key difference is how they handle data. Both start with a snapshot of the current atmosphere. Data assimilation. They pull in observations from weather balloons, satellites, airplanes, and surface stations. The Euro uses a more advanced and computationally expensive method called 4D-VAR. 4D-VAR looks at observations over a time window, creating a more consistent starting point. The models also differ in how they represent physical processes. Clouds, precipitation, surface energy. These are called parameterizations. Different equations for similar processes. Finally, there's ensembles, running the model many times with slight tweaks. This creates a range of outcomes and helps quantify uncertainty. The Euro has a larger ensemble system with more members, often giving it an edge in gauging probabilities. That helps forecasters assign confidence levels to different scenarios, and that brings us to real-world examples where these differences matter. To really understand the difference these models can make, let's travel back in time. Remember the massive blizzard that hit the East Coast in late January 2016? It was a monster storm, dropping over 2 feet of snow on cities like Washington, D.C., Baltimore, New York City. In the week leading up, the two models were telling very different stories. More than a week out, the Euro latched onto a major coastal storm. Meanwhile, the GFS looked much weaker, sometimes keeping the storm out to sea. That disagreement created a lot of uncertainty for forecasters. Do we warn people based on the Euro, or play it cautious with the GFS? As the event neared, the pressure mounted. The Euro held its ground, stubborn and consistent. The GFS, on the other hand, was flip-flopping. In the end, the Euro model was the clear winner. Its forecast matched the actual storm track, intensity, and heavy snow zones. The GFS eventually came around, but much later in the game. This event cemented the Euro's reputation as the king of medium-range storm forecasting. It was a powerful lesson in trusting the model with the better track record. When it comes to winter, the biggest question is always, how much snow am I going to get? Predicting snowfall is one of the hardest jobs in meteorology. It's not just precipitation, it's the temperature from cloud to ground. A change of 1 or 2 degrees can mean the difference between a foot of snow, a miserable icy mix of sleet, or just a cold rain. This is where model resolution and physics really come into play. Different physics and parameterizations affect predictions of narrow snow bands and rain snow lines. The Euro, with higher resolution and sophisticated physics, often has an edge resolving narrow, heavy snow bands. It can better identify the precise rain-snow line. The GFS is a strong competitor, especially after recent upgrades. It sometimes shines at identifying upslope snow in mountainous regions like the Rockies. Both models struggle with the snow-to-liquid ratio, how much snow comes from a given amount of water. Typical is 10:1, but it can vary to 20:1 in very cold air, or 5:1 in heavy wet snow. Getting that ratio or tiny temp differences wrong can create a bust, a forecast way off. This is the constant challenge in the snowfall showdown. Forecasters must weigh resolution, physics, and past performance to pick the best forecast. After the snow, the next big question is always about the cold. How low will the temperatures go? Will it be a bone-chilling Arctic blast or a typical winter cold spell? Predicting temperature is fundamental, and the Euro and GFS have personalities here too. The tussle is about forecasting massive air mass movements, the jet stream and polar vortex. When a piece of the polar vortex plunges south, it brings extreme cold. The Euro often excels at predicting large-scale patterns and sniffing out cold snaps more than a week out. The GFS sometimes has a long-range cold bias, predicting colder than actual temperatures that ease with time. Accurate temperature forecasts give communities and utilities time to prepare for energy surges and dangers like frozen pipes. They help prevent damage and keep people safe. The GFS's detailed land surface model often captures snow cover effects and daily temperature swings well. It can accurately predict how cold a calm, clear night will get after fresh snow. Forecasters know to view long-range GFS cold signals with caution and cross-check with other models. Next, pinpointing exactly where a storm will hit. The path a winter storm takes, its track, is everything. A shift of just 50 miles can mean a blizzard or a glancing blow. This is the high-stakes storm track smackdown. Pinpointing the exact path depends on steering currents up high and interactions between systems. Tiny errors in a model's initialization can blow up into huge forecast differences. Like launching a rocket, a small angle error misses the target by miles. Historically, the Euro built its legendary rep resolving steering currents and nailing East Coast tracks. Especially with major East Coast snowstorms, it often nailed the track days out. The GFS historically lagged, but recent upgrades have made it much stronger. We now see more cases where GFS is right or close to the Euro. When models disagree, forecasting gets tougher. We must dig into ensembles to find why. Analysts examine ensemble spread and member behavior to pick the best solution. The Euro also famously predicted Hurricane Sandy's left hook more than a week out, a skill at resolving steering currents. That skill gives forecasters more trustworthy, long-range guidance for high-impact storms. But don't count the GFS out. It's an increasingly competitive tool we watch closely. Next, why you should care about model mania. You might be thinking, this is all very interesting, Ginger. But why does a rivalry between two computer models matter to you? The answer is, it matters a lot. Their forecasts directly affect your daily life, your safety, and your wallet, especially in winter. Emergency managers use these forecasts to deploy plows, pre-treat roads, and issue travel warnings. Airlines route planes, prevent delays, or cancel flights based on model guidance. Energy providers use temperature forecasts to predict demand, which affects your bills. Retailers, crews, and consumers all react. Shovels, salt, soup, forecasts drive behavior. Accurate forecasts keep infrastructure running and communities safe. When you see me explain why Euro and GFS disagree, I'm showing the uncertainty, the range of possibilities. Prepare for the likely outcome, but respect the worst case. Understanding these models makes you a smarter consumer of weather info. That knowledge is power. Use model consensus and advice from forecasters to make smarter decisions. This is more than a scientific debate. It's about keeping people safe and informed. So, who wins the season? So here we are on the cusp of winter 2025. The big question, which model will win? The gap between the two models is closer than ever. The GFS has made incredible strides. It's a fantastic tool I use every day. But when chips are down for a major 5-7 day storm, I give a slight edge to the ecmwf. The Euro's consistency, superior data assimilation, and higher resolution ensembles give extra clarity when we need it most. It has earned its reputation as the gold standard. That doesn't mean the GFS will be wrong. Many times it will be better, and its open data is invaluable. The rivalry drives innovation. The real winner is you, with better forecasts every year. So get your shovels ready. Let's see what this winter brings. Stay safe.